Okay, hi, this is section 1.4, Physical and Chemical Properties of Matter. We'll also consider intensive versus extensive properties. Substances are identified by their properties as well as their composition. Color, melting point, boiling point, and density are physical properties. By that we mean they can be measured and observed without changing the composition or identity of a substance For example, we can measure the melting point of ice by heating that block of ice and recording the temperature at which the ice is converted to water. It should be 0 degrees Celsius. Water differs from ice only in its appearance and not in its composition, still H2O, so this is a physical change. We could freeze the water to recover the original ice. Therefore, the melting point, or the freezing point, of a substance, and by the way, melting point and freezing point occur at the exact same number for a substance, is a physical property. Note also that there's no point in taking the melting point of a mixture because mixtures have varying compositions and you're going to get varying numbers. Similarly, when we say that helium gas is lighter than air, we are referring to a physical property. Also, if anybody's ever tried to take the melting point of a mixture, it just doesn't work very well. You typically get a huge range. On the other hand, the statement hydrogen gas burns in oxygen gas to form water describes a chemical reaction. So this is a chemical property of hydrogen, its flammability. Because to observe this property, we must carry out a chemical change. In this case, burning or combustion. After the change, the original substances, hydrogen and oxygen gas, will have vanished. Now notice those are the hydrogen molecules and the oxygen molecules. The hydrogen has not vanished, it has rearranged itself to form a new substance known as water that contains those atoms. We cannot recover hydrogen and oxygen from water by a physical change such as boiling or freezing. You're making something new. It's oftentimes thought of as a destructive process. For example, if you want to analyze something using a chemical method, well, you're going to lose it. If you want to analyze something using a physical method, you're usually better off because it does not destroy your sample. Every time we hard boil an egg, we bring about a chemical change. When subjected to a temperature of about 100 degrees Celsius, the yolk and the egg white undergo reactions that alter not only their physical appearance, but their chemical makeup as well. When eaten, the egg is changed again, I'll say, by substances in the body called enzymes. This digestive action is another example of a chemical change. What happens during such a process depends on the chemical properties of the specific enzymes and of the food involved, I'm sure. All measurable properties of matter fall into two categories, extensive and intensive properties. The measured value of an extensive property depends on how much matter is being considered. Notice the word extent hiding within there, so that's how I always remember it. Extensive properties are extent or amount dependent, and it's oftentimes quite silly. For example, mass is an extensive property. If you have more matter, you have more mass. Mass, length, and volume are extensive properties. More matter means more mass. Values of the same extensive properties can be added together. For example, 2 copper pennies have a combined mass that is the sum of their masses of each penny, and the total volume occupied in the water in 2 beakers is the sum of the volumes of the water in each of the beakers. Notice that they're the same substance. Volumes are additive as long as you have the same substance. The measured value of an intensive property does not depend on the amount of matter being considered. It's amount independent. Temperature is an intensive property. Suppose that we have 2 beakers of water at the same temperature. If we combine them to make a single quantity, the temperature of the water will be the same as it was in the 2 separate beakers. That's a very good explanation, I think. Density is similar. If you have the density of a small amount of water, it's 1 gram per milliliter. If you have several gallons, it's still 1 gram per milliliter. Unlike mass and volume, temperatures and other intensive properties such as melting point and boiling point and density, they're claiming that density is an intensive property. I would intensive. Good. Yes. Melting point, boiling point, density, it doesn't matter how much you have, that number will still always be the same. I agree. Let's see if there's anything more. Nope, that's it. This is section 1.4.